Okay, so this is going to be questions 3 D, E, F from this extra exact value practice sheet that I gave you, okay? So what we find here is tan squared theta is going to equal 1, and I'm interested in what theta is from 0 to 360. So what I'm going to do here is, in order to get tangent by itself, I'm going to square root both sides. But the catch here is, which I think lots of us would forget to do, is anytime I square root both sides, I must include the plus minus. Okay, so that must mean that tan theta equals positive 1 and tan theta is equal to negative 1. Okay, remember I can divide by 1, divide by 1. So the only way, of the three triangles, the one that gives me a ratio of 1 over 1 is going to be this 45. A ratio for tangent of 1 over 1 is going to be the 45-degree triangle. So that's what I'm going to draw. I'm going to draw all instances where tangent is positive as well as negative for this question. It's a little bit different. It's trickier, right? So here, let's draw our Cartesian grid. Get x, y, negative x, and negative y. And I'm looking for all places. So if this is C, A, S, T, let's do the positive ones first. So where is tangent positive? Tangent's going to be positive here and here. Okay, and then I'm also interested in where's tangent negative. Oh, that's here. And here. Okay, so the triangles aren't quite perfect, but you get the point. We already established that the only way to create a ratio of 1 over 1 or negative 1 over 1 is with the 45-degree triangle. So there's 1, there's 1, there's 1, and there's 1. Okay, so we get theta is going to equal 45 degrees. We're going to get that theta is going to be 135 degrees, 225, and finally 315. So you get 4 answers for this question from 0 to 360, which is an interesting one. Okay, we recall, yes, like we would have changed this question from 0 to 360, which is why we're getting more answers, not just 0 to 90. Okay, okay, the cosine squared, 2 cos squared is equal to 3 over 2. That's going to be the next question. So 2 cos squared theta is going to equal 3 by 2. Okay. So for this question, like usual, what I'm going to do is just divide both sides by 2. Right? Divide by 2. And I'm going to get cos squared theta is going to equal, now you've got fractions inside of fractions, right? So when I take 3/2 and I divide it by 2 again, I'm going to get 3 over 2 multiplied by 1/2. Sorry, it's a little tight. I'll move that. Okay. And then so subsequently I get cos squared theta is going to equal 3 by 4. Now, I'm now interested in getting just cos theta by itself because it's cos squared theta at the moment. So I'm going to square root both sides. And again, like the last question, when you square root both sides, you got to write the plus minus. And so I get cos theta is going to be root 3, by the square root of 4 is 2. So now you got to ask yourself, oh, and it's plus minus. Don't forget that. That's close. I almost forgot that. Okay, so you ask yourself, where is cosine positive? Let's do those ones first. Cosine is going to be positive. Cosine is going to be positive here. And cosine is going to be positive here. try and do that better. Okay, and then that's the positive ones. And I also need the negative ones too with this question because I've got the plus minus, right? So I'm going to come over here and down and here and up. Now our question has to be, how do I get a ratio of root 3 by 2? Well, the 2 in the denominator indicates that it has to be the 30, 60, 90 triangle, not the 45, because you get a root 2 on the hypotenuse for that one. And then it says that a cosine is going to be adjacent by hypotenuse. So that must mean that in each of these triangles, this side length here must be root 3 for all of these, right? So if that's root 3, then that must be 60, and subsequently that must be 30. So we're dealing with the 30-degree triangle all the way around, which must mean that theta must be 30 degrees, 150 degrees, 210, and finally this is going to be 330, right? All the way around. Oops. Okay, so there you have it there. Okay, one more, question F. Let's take a look at F. What's F say? F says root 2 by 2, root 2 by 2 sine theta has to equal 1/2. Well, let's just try and get or isolate sine theta, right? So I'm going to go multiply both sides by 2, right? Because that's division on the left. And so if I do that, I'm going to get root 2 sine theta has to equal 2 over 2, which is just going to be 1. And then in the next one, I can just go divided by root 2, right? And so I get sine theta is going to equal 1 divided by root 2. And so I'm looking for where is sine theta positive, right? So sine is positive in 2 quadrants. One there in the L quadrant and in the S quadrant, right? So I'm going to get here, sine's positive, and over here, sine's positive. Now, the only way to get a root 2, remember this is going to be opposite over hypotenuse, right? For sine. So opposite is going to be 1, and the hypotenuse is going to be root 2, 1, root 2. And so we know if I have a root 2 in the triangle, it has to be the 45. And so we know that theta in this question, for question F, is going to be 45 degrees, and theta is going to be 135 on the other side. That's it. Okay, so that's just a little recap of some exact value work. Those are a little tougher questions than what we've seen so far on this sheet, particularly D, E, and F. Just a couple little subtle differences there, okay? So we'll see you on the next